Hello, hi, welcome to my channel. After watching this tutorial, you will be able to find soil depletion mean values for your study area by using RUSLE model. So first of all, let me explain what is actually RUSLE. It is revised universal soil loss equation which we actually use to calculate soil loss, soil erosion. So how actually we calculate? We actually calculate different factors to get soil loss, soil erosion values. And the factors are, first of all, it is R factor, which is actually rain runoff erosivity factor. The second one is K, which is actually soil erodibility factor, and LS is basically, L is like slope length factor and S is the slope steepness factor, while C is cover management factor and P stands for the practices that supports the erosivity for long term years. But for further, you can search over Google and read about RUSLE model. So let's start. So before going to start, we have to load our different data sets to perform this analysis because we need to calculate different factors which require different data sets. So first of all, let me show you that how you actually get, then I will move toward the code session. So here's, you can see, for example, this is my study area of Rajanpur districts over here in Pakistan, and here are the actually factors that I calculated to actually get the soil depletion, and it's represented in tons per hectare per year. So let me show you different factors which are being loaded. For example, area of interest actually is my this shapefile, and these are the factors actually I calculated to reach actually on this class, which is actually soil loss, soil depletion class. At the end it will represent our soil loss class. Let me show you, then I will move towards the code section. Here you can see it's loading different layers, and now we are close to our final layer, which is actually this one. So here you can see, like, this one is significant, here you can see situation is alarming, and the red one is like hazardous, and this one is like minor, normal. So this way you can identify your study area. So what you have to do, and here you can get pie chart which actually shows like how much percentage is like minor, it's normal, it's like significant, 9% alarming situation here, and 16% hazardous. You can even like get it on big screen. Soil depletion, here I also calculated the precipitation time series. Actually I'm calculating it for 2022 from first month to fifth. So you can see here I also like generated precipitation chart. So via this way you can get different things. So let's begin our code. So first of all, and here you can see the mean value and feature, I will explain later. So let's start our code. First of all, you have to define your area of interest. This is my actually shapefile and table ID. You have to, if you have shapefile in your Google Earth Engine assets, you can simply copy your table ID and paste over here. No need to change the code, just replace this area of interest and you will get the whole map for your study area. It's very simple. So it's my area of interest basin. Actually basin we need, on this we will actually calculate our further analysis. So for the basins I am using the Google Earth Engine datasets hydroshed, but you can also use external sources, like for example you can import your basin from your, like if you have external shapefile of your basin, you can simply export and perform this analysis on your external basin. You just have to load your basin here, and you have to load your basin as variable with, and you can just perform your analysis on your external basin file. But you can also use this one. And here I am using MODIS land cover. You can use like dynamic land cover, which is latest one. You can also go for that. And here's the actually soil class, which is like which we actually use further, and it's very important factor. And here the sentinel I'm using to compute NDVI, and here's the dam, which we will actually use to compute slope uh, for L and S, as I explained earlier. To we will calculate actually LS factor with this dam, and chips we will actually use this datasets to this dataset to calculate our R factor. So after loading these datasets, you have to define your date range for which you actually want to perform your analysis. For example, I wanted this for 2022 from 1st month to the 5th. So you can do, if you want, you can like type here for 12th. So it's up to you how much or what is your minimum requirement for how long you want to use this. Okay, after loading all of your data sets and your shapefile address, then you have to uh, set your study area as a center object, as I just, so you don't have to like modify the other code. If you just type the whole code that I will explain, then you just have to replace this one, then you will get the whole code done for your study area. It's very simple and easy, but I'm still explaining, and you can get the code. So here, after loading the datasets, then you have to define your desired date range. After date range, then I clip datasets to area of interest. Like for example, these are the datasets. When you will load them directly, it will like cover the whole world map, but we have to focus on our actually our area of interest. To do that, we have to clip our area of interest. And what I did, I clipped everything. I clipped like chips data, I clipped soil data, dam data, and I also clipped this to sentinel, on which we will compute NDVI, and I clipped my MODIS land cover data. So after clipping data, so we have to now calculate the most important step, are the factors which we have to calculate. So first of all, for example, we will calculate our R factor, which is rain factor. R factor actually determining its erosivity and amount of rainfall and peak intensity over an extended period. So for that we will use CHIRPS dataset, and we will apply the formula. You can read different articles and to perform to change values. So these values are by formulas. And then K factor is for soil erodibility, which is actually soil erodibility factor. To calculate soil factor, we will actually use soil dataset from USDA. And remember, those all others are like feature collections or image collection, but this soil one is actually one single image. So you have to keep in mind if you're doing this one. So it's one, just a single image, it's not an image collection. So we will actually use this soil to calculate our K factor, and for it we will also generate our soil expression later. I will show you in code. So then you have to load the then you have to add the layer, as I just loaded. So here let me explain it again. First of all, make your datasets ready, add your shapefile, define your date range, then clip dataset to area of interest. After that, we have to calculate the most important things, that are our factors. So first of all, we calculated R factor using chirps, then we calculated K factor by using soil, by USDA classification system, like we used soil texture. And here's the another important thing, that soil expression, which we actually use to calculate our soil K factor. So you can like get this one over different literatures on Google from, so you have to set it according to your specific needs, according to your study area, but these are like some general values you can apply on. And after that, you have to clip your area of interest. And here's I just add a layer, and there are different color palettes I used. Especially I my focus was to load the soils in different color palettes. I will show you that how I loaded soils, and I actually used different color combinations to make it more beautiful and appealing. After that, the another main factor is, that is L factor and S factor. So for that we used dam. So it's up to you, you can use 30-meter dam or 90-meter dam. So it's up to you what kind of area you working on. If you are working on plain area, then I suggest you go with SRTM 90-meter data. If your area is like very much mountainous, very much hilly, then you can go for sentinel sorry SRTM 30-meter data. So because 90-meter data is perfect for plain area, if you just compare these two data sets, while the 30-meter resolution is good, but it does not gives accurate slope on plain area. So you have to keep in mind, if you are working on plain area, you can use SRTM 90-meter. If you are working on like hilly or other area, then 30-meter SRTM dam by NASA USGS is good for you. So after that, we have to calculate slope in percentage. So here's the formula, divided by 180 multiplied by math and pi, and pi, so and then also multiply 10 into multiply by 100. So here's the formula, and you can like modify this according to your specific needs and according to the literature that you'll read. You can just simplify and you can just modify this code accordingly. So here, after calculating SLS factor, we move on to our next factor, which is C factor, by using NDVI. So this C factor can be done by many ways, but I am using here C factor by using NDVI. And for NDVI, we actually used Sentinel-2 data to compute our NDVI. So I computed NDVI and I clipped my area of interest, and I then loaded color map palette for NDVI. After NDVI calculations, here's the thing, you can set max value, like for example you can set 2 into 12, 2 into 9, or whatever. It's up to your specific area, so you can just adjust. So after that, we move to the next our factor, which is our P factor. Actually, P factor reflects the impact of sport practices and the average annual erosion rate. So for average annual erosion rate, we actually use P factors. By combining these all factors, then we at the end get soil depletion. So P factor is our last factor. So then we will move on to the soil depletion calculation. So for P factor, we used land cover by MODIS. Okay, and and I used MODIS land cover type 1 and I clipped my area of interest. If you want to read MODIS documentation, you can simply check my dataset and you can read MODIS documentation. And you can also like generate this soil expression by yourself, and there are many like available on internet. You can get any from net. Then you have to clip your area of interest. Okay, so these were like our all the factors that we just calculated. Now the next one is we have to make our beautiful color map layers. For that I use general variable style, which I will use further to color my maps. So for soil depletion I actually use this color palette. You can use this one, it's very appealing and vibrant. So after calculating all the factors, I just calculated mean soil value, and then I calculated basin area. If you want to get like in task, you can get your sub basin areas from here, and you can like run and you can get this data in CSV format, and you can make further graphs or whatever. You can play you can play with the data in Microsoft Excel. So it's up to you, or you can also generate graph through R language. So after that, after calculations and adding layers, these are like sub-basin area. Then I loaded the legend panel. You can also create one like this. So it's up to you. Like for example, here the value here is actually the title, which I just wrote like soil depletion tons per hectare per year. It's actually the the representing unit for soil depletion or soil loss. So it's up to you how much font size you want to keep or how much you are okay to go with. And then I added the legend. So here's the code, and here's like classes I defined for for each, and then finally I loaded, and here's the code to print time series of rainfall data, like time series chart for rainfall data. For precipitation time series I just added this chart, and you can see here's the precipitation time series and here the pie chart. So here's the code. Now I will show you different examples, so you can just note down this code or you can take screenshots and then you can write it in your own system. So I am just moving this one for you guys, so you can like slowly pause my video and take screenshots and you can write the whole code. So it's very simple, easy. You just have to replace your shapefile. So here I'm showing you the full code. So you just have to replace your area of interest and you will get the whole model for your study area. Now let me show you different examples. For example, I'm just, but before going to change area of interest, let me show you the results. So this one is actually our main map layer, and for other factor you can also like watch them, that how they are like here the like p factor. Here is like different factor you can see. I just calculated to reach at that point, and I mostly focused on soil color palettes to make it more vibrant and appealing. Now let me show you this on different area of interest. I mean to say on different shape files that you can change. So first of all, you have to move on to your assets, and then for example I want it for let me choose another study area. I want it for this city of Russia. Just simply copying the table ID and just replace this one pasting and click on run, and you will get your study area soil depletion map. So it's very simple, very easy. You just have to replace the study area like shapefile, and you will get your whole study area maps on single click. So here's the result, you can see. And here you can see our final layer, and here you can see it's like pie chart and the time series chart, and you can open further, and you can also get this data in CSV. And here the time series chart. You can try on different areas. For example, I'm just showing you it with different areas. You can try on. It's very simple. Just replace your area of interest shapefile ID and paste, and click on run. You will get your study area map. Now the most important point that I will show you after this, sorry, I apologize, I forgot to replace by this ID. Now the most important point that I want to show you is via this inspection tool you will actually get what's going on. So here you can see the mean soil depletion value, and here you can see mean soil depletion values pie chart. Here you can see. Now that's the main point, inspection. Now I will show you how you can inspect your data. So first of all, it's being loaded, so I'm just waiting for its completion. Here's the final layer, and now that's the point. Now here's the main point, that like on this point you can click and you can get the whole detail like annual rain, precipitation, R factor value, soil value, K factor map, soil in slope in percentage, and then NDVI value like 0.2, and land cover. Different values you can get from this inspection tool, and it will tell you that lat long. So, and at 153 pixel, what is this pixel value? Actually we use this pixel value in actually in our remote sensing. So here it's like this kind of pixel value which we are actually using as an formula, but you will read different articles and things, then you will get more clarity about it. So via this way you can get your study area pie chart maps and precipitation series and soil depletion finally map. I hope that you find this tutorial interesting. So please subscribe to my channel and support. Thank you. Have a nice day. Stay blessed. Bye bye. Take care.